Hello everyone, welcome to our YouTube class. Today we are going to discuss on circular motion. So when an object moves around in a circular path, the object constantly changes its direction. So if we just draw a circle and we consider the object is moving along the direction that I drew with the arrow sign in anti-clockwise direction, that is representing how the object is moving round. So it is moving in a circular motion in anti-clockwise direction. And wherever the object is, its velocity that is acting along the tangential direction. So what I was saying is that when the object is moving around in a circular motion, in a circle, the direction of the object continuously changes. And as the direction changes, the velocity changes because velocity is a vector quantity. Now you see the direction of the velocity at any particular point is along the tangent. So when we see at this point, that point, we do not see the velocity to be acting in the same direction. The velocity kept changing the direction, and these are the 4 points we located on the circle, and we see the direction of the velocity at each point. So since the velocity changes and rate of change of velocity is acceleration, so when an object is moving around in a circular motion in a circular track, it always accelerates, although the object is moving at a constant speed. So here is the first question comes in this chapter, that though the object is moving at constant speed, how can it accelerate? It is accelerating because speed is constant, but the velocity is not. Acceleration is not defined with respect to speed, rather it is defined in terms of velocity. It is rate of change of velocity. So there is a change in velocity with respect to time, because you know that object needs some time to change its position from one point to another point in this circular track. So this is why there is an acceleration, there is a change of velocity with respect to time, and this acceleration acts towards the center of the circle, and that is why it is known as centripetal acceleration. Centripetal is a Latin word. Centri means center, petal means seeking. Center seeking acceleration means the acceleration acts towards the center of the circle. Now you know that Newton's second law, that resultant force F net is equal to mass times acceleration. So with this formula we can relate that acceleration must be acting in the direction of the resultant force. And since the acceleration is acting towards the center, it means obviously the force that is causing the object to move around in a circular track is also acting in the also acting towards the center. So the force is acting towards the center, so is the acceleration. That's why this force also is known as centripetal force. And centripetal force is nothing but a resultant force, a net force. This is the force that produces the acceleration. Here, the acceleration of the object is due to the change in velocity, and change in velocity takes place due to the change in direction. So you can relate this with the Newton's laws of motion that you studied in your AS, that without applying the force, an object cannot change the direction. So for the object to change its direction, the force must be needed. And this force is nothing but the resultant force, the net force. And here we say that centripetal force is required for the object to move around in a circular track. Yes, if there is no centripetal force, the object will be flying along the tangential direction, the line, the arrow that is indicated by the velocity. So if at any particular point the centripetal force is no longer acting on the object, from that particular point the object would be flying off tangentially. So it is just following the Newton's first law. It means at any particular point there is no resultant force, no change in direction will take place, so it would be moving along the straight line direction. Newton's first law said that if there is no force acting on the object and it was in motion, then it will keep its motion continued with the constant velocity. So there is no when there is no resultant force, the object will no longer be able to move in a circular track. All right. And when we say the object is in uniform circular motion, so what does this uniform refer to? Uniform means the object is moving at a constant speed and constant radius. It will have the constant radius r, and it will have the constant speed as well. But velocity is not constant. Do remember this thing. All right. So whenever the object is in circular motion, it is obvious that object has been provided with some resultant force, and this resultant force continuously keeps the object changing its direction, and this makes a circle. All right. So another thing is that centripetal force is not the type of a force, it is just the name of a force. What do you understand by this? It is not a type of the force. What do you understand by type of a force? Say we are familiar with the type of the force as gravitational force, as electrostatic force, magnetic force, contact force, tension, friction, upthrust. These are the type of the forces. Now, when we say centripetal force is not the type of the force, it is just the name, what does it mean? It means whenever an object is moving around in a circular motion, that means centripetal force must act on the object. Now, depending on the situation, you have to find out, you have to identify which particular force is responsible to provide this much centripetal force. As you see in example 1, the earth is revolving around the sun. So how can earth revolve around the sun? It is because of the gravitational force. So the gravitational force existing between sun and earth is providing the required centripetal force. In the second example, you see the electron is orbiting the nucleus. Electron, being negative charge, is orbiting a positive charge nucleus. Why is it so? It is because the electric force between these two charges is providing the required centripetal force, which is why this electron is orbiting the nucleus. So there are numerous examples in this regard you can find. For an example, I can say that um, you know you tied up an object at the end of a string and you keep on whirling the string so that the object moves around in a circular path. So why does the object moves around in a circular path when you just tied up it at the end of a string and you whirled around? It is because the tension here is providing the centripetal force. So this is what we say, that centripetal force is just the name of the force, not the type. So this is just the beginning of the circular motion. So we will keep on continuing the discussion of the circular motion thoroughly. So I hope you understood whatever we have discussed so far. Later we'll be going in details of the circular motion. Thank you for watching this video.